Welcome. This is another technician video brought to you from Diag. And the title of this video is Battery Starting and Charging System Diagnosis with the Micsig, the 3-channel scope. As we look in the engine compartment, we're going to be rolling with 3 channels. Channel blue, the second channel, is going to be on the battery, looking at battery voltage. Channel purple, the 4th channel, is going to be a high amp clamp wrapped around the negative battery cable, which will determine the cranking current as the vehicle starts. And our other high amp clamp is on the output of the alternator, which will determine the current coming out of the alternator, which is a really good way to look at charging systems from a complete perspective, because we have the rush-in current that once the car starts, we know that. We also know what the alternator's outputting. So anyway, I will go to the just want to make one that if we look at the clamp, our attenuation is 1 millivolt per amp for both clamps. So that's going to make it easier once we set up the vertical side of the scope, which is going to be in millivolts. It would give us a proper range so we make good use of the screen. So right now we're going to be at 5 seconds per division, and I will once I get the capture, I'm going to. The scope has very good zoom capabilities. I don't believe it buffers multiple screens. I don't know that. I haven't. I'm just learning this piece of equipment, but nonetheless, we're going to zoom in on that once we get the capture. It's going to be from the car being off to cranking, running, and then added electrical loads while running, and then shut off, and then the scope stopped. So as you can see, our channel blue, we're on 2 volts per division, which gives us a good range of the battery. Purple, which is the high amp clamp at the battery, we're 100 millivolts per division, which gives us at least 1,000 amps of range. And the green is at 50 millivolts per division, which gives us probably about 200 amps of range, because some alternators do get very high as they charge. So basically, I'm just kind of watching the capture. I'm going to wait till I got a full screen before I start the vehicle. It's kind of in roll mode now. It's just rolling across the screen. No particular place to go, and we're just watching it go across, and I'm almost there. Once I get the capture, the entire capture will be on one screen, and then I'll be able to zoom in on aspects of the screen. I'll take each channel one at a time with the cursors. I guess they call them the vertical cursors. They're going to be the cursors going like a line going across the screen, much like the signals are right now. And we'll talk about each measurement one channel at a time through the event of basically key off to cranking to running, and then the alternator feeding electrical loads and then stopping. So here we go. We're on the screen. You can see the left side of the screen. That's basically battery voltage. We'll measure that later. I'm grabbing the key now. I will start the vehicle. You're going to see things. The recording will probably be a lot better because we'll be zoomed in. This is a tight. We got a lot of time on the scope here, so I'm just going to kind of take my time and do a few different things. I want to raise the RPM. I want to put the rear defroster on. I want to put the blower motor on. I want to step on the brake pedal, and I want to. What other load can I use? I don't want to put the wipers on. Basically, I'm going to turn those loads off, the defroster off. You can see the action chain. We're going to see that more dynamically once we zoom in. Basically, that's the alternator changing and battery voltage changing as the charging system requires more or less current to work properly. I will take the mouse. This is a mouse. You can use a mouse with this tool. I will right click and stop. Wow, that was close. Now you don't believe how close that was. I almost had to redo, but nonetheless, we did get a capture, and I will talk about it. We'll talk about one channel at a time. We are stopped. Let me get rid of that. We're going to talk about the blue channel first, which is battery voltage. Let me shut the car off. So we can, basically, that's our crank. That's our battery voltage. So I'm going to go in the range of this capture here. I'm gonna go from 5 seconds. I'll probably go to 500 milliseconds and maybe over to 200 milliseconds. Depends on what we're looking at. The real meat and potatoes capture is the cranking event, that moment in time when I turned the key and went to starting. So I want to key in on that so I can go here, right here, and I'll drag it back to right here. We can see this. I go 500. I'm going to go to 200 to look at this, and you can see right now we got pretty good capture here. Maybe I'll go 100. It's always tempting with a scope sometimes. That's a little too much. You get a little, your eyes get too big for your head sometimes. So let's look at blue. That's our battery voltage during the events of me cranking it and then on into running. So with this scope, we go down here. I'm gonna get the cursors going. I'm gonna drag up. This is the cursors I need. I want the cursors for blue, so I click on blue, and now I got this cursor here. So that's here. I'm looking at battery voltage before I started the car. We'll kind of key in on that. That's about. Let me get closer. Okay, that's about 12. You can see that. That's about 1254 right there. About 1256. That's a properly charged battery. Then the moment I turn the key is probably right here. You can see the little dip there. And then you've got to that moment, the point of lowest voltage, that moment in time. I've done this in other videos. I was always taught to be north of 8.5. Right now about 924. That's that moment, that lowest moment, initially when the starter just starts to spool and starts moving. Now here's our kind of our cranking moment. We're cranking here. The battery voltage is maintaining 11.2, which is good. I've always wanted to be north of 10.5 in a situation like this. It's not the fastest starting car in the world. Nonetheless, it doesn't bother me, but nonetheless, there's a little bit of cranking time here. And then the alternator starts to kick in and we start charging. Now I'm going to do something to time. I'm going to go to like maybe 500 milliseconds, or maybe the other way. And I want to start to move across. We just want to concentrate on blue. My cursors kind of threw me a little bait and switch on the cursors. I'm going to have to get back to the blue cursor. So I click here, and then I get my cursor back. Yeah, that's the thing with this scope. Now this is our moment when we're running. We're just looking at voltage now. So we're charging about 14.14 right here, and I'm just going across. And the cursors did their little bait and switch again. That's been happening, so I'm going to have to get the blue guy back. Nonetheless, I got the blue guy's coming back. He seems to like going and run away. So there we go. There's the when I started to load the electrical system. You can see we have a little drop in voltage, about 1292. This does have that ELD on Hondas where they sort of control the alternator with through the PCM, and sometimes you got to be mindful of that. They don't always charge 14 volts right off the bat. They have that electrical load detector. Just be careful when you're diagnosing a Honda. So nonetheless, that's basically the rest of the sweep. That's basically voltage. I'm more concerned with current. Obviously, I probably increased or took the electrical loads off, and there you can see the voltage rising. I'm going to go back to the cursor. There we go, right here. And we're about 14, looks like about 14.48 as I go across. And now we're gonna I'm gonna go back to I'm gonna look at the other channels, and we'll go back to 5 seconds per division. That's our original time when I initially took the capture. Let's just talk about purple. Purple was that high amp clamp at the battery cable. That was the starter current leaving the battery when I cranked it and on into running. And then down, once it gets running, we call that rushing current. So let me mess with the time, and I want to get it, no, the other way. Let me go about this to about 500. Let me get to that moment in time. Okay, that's our spot. I gotta key in maybe 200. You can see that. Now you can see basically our rushing current right here. And let me get the cursors, and maybe they don't do their little trick with me right here. Back to the purple cursor. Okay, rushing current. Remember, 1 millivolt per amp. At millivolts, I got about 718 at the top of that's the rushing current. That's the highest. That's pretty good. It's not excessive. Initially, it takes a lot of amperage to get a car cranking, and basically it settles down to about right here to about 142 amps. That's the relative compression zone, I guess you can call it that. I call it that, I don't know. And then the alternator starts to put back in. Look at this. We're going to see all this in green, but in a more granulated value when we look at the alternator output. That's the current going the other way. That's going back into the battery, that big electron hole that was created because the battery gave up a lot to start the car. Now it's getting repaid, and we can see about 102 up here. That's about 102 amps going the other way into the battery, but that's just a moment in time. The rush-in current starts to get more stable, and we're back down to about 28 amps. Remember, millivolts equal amps, one millivolt per amp in this with these two clamps. So basically, I will start going across the screen, and we'll kind of analyze purple. I think green will give us more information because it has a tighter range. When I let me go to 500, so I can just move quicker. Okay, here's when I did I added some electrical loads. Remember, I was working with the headlights and the rear defroster, stuff like that. You can see some in purple here, but basically this really kind of shows out more in the green channel. So I'm gonna get the cursor over to green right here, and here's our green cursor, and I'll roll it back to that spot when we started, and I'll go this way. You kind of get a feel for it. There's our moment. Here's that interesting piece. You see that's that moment right here. That's a lot of, that's a ton of current coming out of the alternator. But this is that brief moment that the alternator needs it. That the battery needs it because of what it gave up to start the car. Then it just kind of settles down to rush-in current about right here. Starts down, it's about 45 amps there. And then we go across. I will increase the time so we don't move so slowly. And there you can see the cursor did its thing again. All right, I got the cursor back, and you can see as we go across, for some reason, okay, there's the different amount of current going out of the alternator to feed the entire electrical system. And you can see here when things change, when there's less current coming out of the alternator when I turn those components off. And also the battery voltage did go up. Let me get back to about 1 second. And you can see right here, basically, I'm going to get back to the original section where we started, back to 5 seconds per division, to kind of get a baseline, get my bearings here. So basically, that's our signal. And with this capture, we can analyze a lot about the charging system. We also, we can analyze our right here, our start is where our open circuit voltage for the battery. Then the moment it starts, we could look in and see that this information here tells us the condition of the starter. We don't have any southward spikes going south. That would indicate commutator bar issues on the starter. That could cause an intermittent no crank. We're good on the alternator. The alternator is still strong. The battery didn't go too low. The relative compression, well, basically we're not doing an engine analysis, but done that, always it may give up information that's vital. But anyway, this is the meat and potatoes right here, and with this tool, it has a really nice, it's kind of quick and run and gun. You can do this diagnosis on a mobile call or in the parking lot. I like to use the extra clamp just because I want to see the alternator. Most people would do it with 2 clamps, and there's nothing wrong with that. I think a combination of an amp clamp and another voltage channel when you're doing this on a scope is a very good method to diagnose a battery, a starting, and a charging system. Anyway, thanks for watching. I'm signing off from Diag Nation.